Have you ever felt like you're just drowning in information, maybe wishing there was some secret shortcut to just get what's important, like instantly?
Oh, definitely. Or that feeling you get with AI.
Exactly. Or maybe you've played around with AI chatbots and, they're impressive, but then you think, this is cool, but I wish it could actually do more for me.
Right. Beyond just chatting.
Yeah, like actually update my calendar or, I don't know, send an email, maybe pull up real-time sales data without me having to ask 5 different ways.
Yeah, that real-world connection has been the tricky part.
Well, for too long, connecting AI to the real world has been kind of a nightmare, right? Custom code, endless adapters, just this tangled mess.
Absolutely. A huge integration headache.
But today, we're diving deep into something that promises to untangle all of that. Imagine, if you will, if all your devices could finally connect with one single universal port. No more drawers full of proprietary cables.
Like USB-C finally arriving for everything.
Exactly like that.
Yeah.
Well, for AI, that unifying port is arriving, and it's called the Model Context Protocol, or MCP.
MCP, yeah.
It's been described as the USB-C port for AI, which I love. Even more playfully, the taco shell for AI. We'll get into that one.
The taco shell, interesting analogy.
We've been immersed in a fascinating stack of material on MCP for you today. I mean, everything from the technical primers to real-world applications and some pretty bold future predictions.
And it's been fast.
So our mission in this deep dive is to explore these insights together, really reveal why this seemingly technical protocol could be a foundational game changer for the future of AI, and frankly, for anyone looking to make AI truly useful and integrated into their lives.
And what's really fascinating here, I think, is how MCP zeroes in on a core problem that has severely limited AI models up to now.
Which is?
It's about finally allowing them to break free from just their isolated training data.
Yeah.
Letting them start taking real-world actions, but in a structured, reliable way. Think of it as bridging that critical gap between what an AI knows from its training and what it can actually do in our interconnected world.
You called MCP a game changer for AI interaction with the real world. So for those of us tracking this rapid AI evolution, what exactly is the Model Context Protocol? Why is it such a fundamental shift?
Okay, so at its core, MCP is an open standard. And it's designed specifically to enable large language models, LLMs, to interact with external tools and data sources.
External tools? Like what?
Anything, really.
Yeah.
Databases, APIs, your calendar, email, image generators. But the key is it does it in a unified, standardized way.
Standardized, that sounds important.
Hugely. It was introduced by Anthropic back in late 2024, and honestly, its adoption has been surprisingly rapid, which I think speaks volumes about the very real pain point it solves.
What was that pain point exactly before MCP?
Okay, so imagine this. Before MCP, if you had multiple AI models, maybe one for text, one for code, and you wanted them to interact with multiple external tools.
Like my internal knowledge base, maybe an email sender, perhaps an image generator, my CRM, a calendar app.
Exactly. Connecting them was incredibly complex.
Yeah.
And bespoke.
Yeah.
Every single time.
Meaning lots of custom code.
Tons of it. You were looking at what we call an MECN problem. If you had just, say, 10 different AI models and 10 external tools, you'd potentially need hundreds of custom integrations.
Wow.
Yeah, each one a unique, probably fragile connection point. It was like trying to connect 20 different devices, each with its own unique, obscure plug. I remember one project where, seriously, we spent more time on the integration glue than on the core AI logic itself.
That sounds incredibly inefficient.
It was. This complexity was a massive bottleneck for building truly capable, versatile AI applications.
Okay, so that MXN problem sounds like a complete spaghetti junction of custom code.
Yeah.
If that was the bottleneck, how exactly does MCP cut through that complexity? What's the ingenious part of its design?
The ingenious part is really its simplicity. MCP completely flattens that complexity. It just gets rid of it.
How?
With MCP, each external tool, your database, your API, whatever, and each AI model only needs to speak one language, the MCP standard.
Okay. One standard to rule them all.
Pretty much. This dramatically cuts down integration work from M times N connections down to just M plus N connectors.
M plus N, so just one connector per model and one per tool.
Exactly. Imagine. Every AI application and every external resource now only requires one adapter each, instead of a custom adapter for every single pair. It's truly a plug-and-play model for adding capabilities to AI.
That makes integrations vastly more scalable and manageable, I'd assume.
Immensely so.
So zooming out a bit then, what are the broader implications of this kind of standardization? How does it change the landscape for AI development and deployment?
Oh, the implications are huge. Really huge. First off, this standardization reduces duplication of effort massively. Think of all those custom integrations nobody needs to build anymore.
Right.
It also helps eliminate vendor lock-in. Because you can swap out an LLM, say move from Claude to Gemini or whatever comes next, without having to rebuild all your tool connections from scratch.
Because they all speak MCP.
Precisely. And maybe most importantly, it opens the door for far more powerful integrated AI applications. Well, LLMs can now safely access real-world, up-to-date data. They're not stuck with just their training cutoff.
Yeah.
And they can perform actions that go way beyond just generating text.
So they can actually do things.
Yes. It's a fundamental shift. It's helping AI agents move past just answering questions to truly engaging in complex, interactive workflows that touch various external systems. It gives them real-time situational awareness and the ability to act on it.
Okay, so how does this magic actually happen under the hood? You mentioned it's an open standard. How is it actually structured to achieve this seamless integration?
Right. The real cleverness of MCP isn't just that it connects things, but how elegantly it does it. It follows a client-server architecture, but one designed specifically for AI interaction.
Client-server, okay. Like the web.
Similar concept, yeah. Think of it like this. You have your AI application, the host. This could be a chatbot interface, maybe a plugin in your code editor, or even a desktop AI assistant.
Right.
Now, the host doesn't need to know the intricate, low-level language of every single external tool it might want to use.
That would defeat the purpose.
Exactly. Instead, it interacts through something called an MCP client. This client is just a lightweight bridge, usually part of the host application, and it maintains a dedicated connection to an MCP server.
Okay, so there's a client and a server involved. What does the server do?
The MCP server is the ultimate interpreter here. It's typically a small server. It could be running locally or remotely, and its job is to wrap an external tool or a database or some service.
Wrap it.
Yeah, it takes the system's specific capabilities and exposes them using the standardized MCP language. It essentially makes these complex external systems feel like native extensions of the AI itself.
So the MCP server is the interpreter. That raises a pretty important question then. What exactly can an MCP server offer to an AI? You mentioned building blocks earlier that let an AI interact with the real world.
Yeah, it boils down to three core categories. They're often called primitives or building blocks, and each serves a distinct purpose in giving the AI real-world utility.
Okay, what's the first one?
First, we have tools. Think of these as actions the AI can ask the server to perform.
Actions, like clicking a button.
Sort of, yeah. They are AI-initiated operations, and they usually have side effects in the real world. For example, an AI could invoke a Create Calendar Event tool to actually add an event to your Google Calendar.
Okay.
Or maybe a Query Weather API tool to fetch the live weather data for a specific location. Tools give the AI agency. They allow it to extend its abilities beyond just generating text and take real, actionable steps.
Got it. Tools are for doing things. What's next?
Second are resources. These are different. They provide read-only data to the AI.
Read-only.
Yep. Think of them as documents, or maybe the results of a database query, or other data the AI can retrieve, but crucially cannot modify.
So it's about getting context.
Exactly. They are typically application controlled, meaning the host application, or maybe you, the user, decides when to pull in this data to give the AI context for its task. Examples might include a company policies PDF or a customer database query to get up-to-date client info. Maybe even a livestock ticker feed.
Ah, okay.
Resources feed the AI factual, up-to-date context it might lack from its training data, but without causing any side effects in the external system.
Yeah.
They just provide information.
Okay, that makes sense. Tools for actions, resources for data. What about guiding the AI's behavior or setting up specific workflows? Is there a primitive for that, especially if you want consistency?
Absolutely, and that brings us neatly to the third primitive, prompts.
Prompts. Like the prompts we give to chatbots.
Similar idea, but more structured within MCP. These are predefined templates or instructions that guide the AI's behavior in specific scenarios. They're often user-initiated. Like imagine clicking a button in your application that says Generate Summary.
Right.
That click could trigger an MCP prompt. For instance, an MCP server might offer a prompt like Summarize Document to provide the AI a structured way to distill information according to specific roles. Or maybe a code review checklist prompt to ensure the AI follows company best practices when reviewing code.
So prompts help maintain consistency and quality.
Exactly. They help encapsulate expert know-how, ensure the AI adheres to specific formats or guidelines, and just generally make the AI's output more predictable for certain tasks.
Okay, tools, resources, prompts. That dynamic discovery process you mentioned earlier sounds incredibly powerful. Can you maybe walk us through how that actually works when an AI needs to use one of these primitives? How does it know what's available?
Sure. The elegance is really in that dynamic discovery. When an AI host first connects to an MCP server, they essentially shake hands. They confirm the protocol version they both understand.
Okay, a handshake.
Then the server basically advertises what it offers. It sends over its entire menu of available tools, resources, and prompts. And crucially, this includes clear descriptions of what they do and what parameters or inputs they take.
So it's like the AI asks, what can you do for me?
Exactly. And the server responds with this structured, self-describing list. Then later during a conversation or while working on a task, if the AI decides it needs a particular capability, say, it needs to add something to a calendar.
It knows the server offers a create calendar event tool from that initial handshake.
Precisely. So it sends a request using that tool name, along with the necessary details, via its MCP client. The client forwards it to the server.
And the server.
The server then executes the underlying action, actually talking to the Google Calendar API in this case, or performs the query on the external system. And then the result, like a confirmation or the data requested, is returned back to the AI.
And the AI can then use that result?
Yep, it incorporates that result into its context. Maybe it tells the user, okay, I've added that event to your calendar, and all this happens seamlessly under the hood. It makes every tool or data source look and feel exactly the same to the AI, regardless of who built it or what complex system it actually connects to.
That is pretty elegant. Okay, so now that we understand what MCP is, the primitives, how it's structured, let's bring this to life. We need some compelling real-world examples. What does this all mean for what an AI can actually do today using MCP?
Okay, let's start with a really practical scenario. Imagine you're a content developer, right? And you want an AI assistant to help you create a marketing landing page.
Okay, common task.
With MCP, you can connect your AI assistant, let's say it's Anthropic's Claude, directly to your content management system, your CMS. You'd use a dedicated MCP server for that, like the Directus Content MCP server that exists.
So the AI can talk to the CMS.
Directly. The AI can then interact with the CMS almost as if it were a human editor. You can use tools exposed by the server, like create new page with title X. It can use resources to pull in specific product descriptions or images from your product database.
Without making things up.
Exactly, using real data. And it can even use prompt templates for, say, writing blog posts or structuring content to ensure it matches your brand voice and style guide.
Wow. So the AI could draft the text, fetch the latest product data, and save it directly into the CMS.
Precisely. All without hallucinating product details, using your real, approved data and templates. It transforms the AI from just a text generator into a powerful content assistant working directly within your existing systems.
That's a fantastic example for content generation. What about something more visual? Let's think about generating marketing posters. That often involves both creative image generation and handling specific design assets, right? How does MCP play into that?
It's equally powerful there, actually. We're seeing MCP servers that wrap popular image generation APIs. There's even an open source DLE MCP server.
Okay, so the AI can generate images.
Yep. This lets an AI create and edit images just by calling MCP tools like generate image with a text prompt or maybe edit image with an image ID and some instructions.
Cool.
Now, here's the integration part. Combine this with an MCP resource that points to your company's brand asset library.
So logos, specific fonts, color palette.
Exactly. Your logos, your style guides, pre-approved images. Suddenly, your AI can act as a kind of graphic designer's assistant.
How so?
It could generate a background image using the Day tool, then use the resource to fetch your company logo and specific branding assets, and maybe even use another tool to edit the image to place the logo correctly, all through standardized MCP actions.
So it's a structured, repeatable way for an AI to handle complex visual tasks that, historically required quite deep expertise or manual work.
That's right. It brings structure to that creative process.
These examples really highlight the multimodal and multi-step capabilities, don't they? I mean, the landing page blends database queries with content generation and saving actions. The poster scenario mixes text instructions, data retrieval from asset libraries, and image creation or editing. So Would it be fair to say that MCP provides the glue that lets an LLM orchestrate all these complex pieces?
That's exactly right. MCP provides that standardized glue. It lets an LLM orchestrate these complex pieces in a controlled and predictable way. It enables AIs to take a sequence of actions, perform searches, do calculations, send emails, maybe even interact with IoT devices someday, all through this one unified protocol.
And the alternative would be?
Without this standardization, each one of those actions would require its own custom integration. Building complex, multi-step workflows would be incredibly brittle, time-consuming, and just a nightmare to maintain.
Okay, this shift then from what you called chaotic custom integrations to a truly plug-and-play model for AI capabilities, it obviously offers huge benefits. What are some of the most impactful ones you're seeing emerge from the sources?
Well, first and foremost, I'd say interoperability and flexibility. That's a big one.
Why is that?
Because it's an open standard. It's vendor agnostic and model agnostic. That means you can swap out LLMs, maybe try Anthropic's Claude today, Google's Gemini tomorrow, without losing access to all the tools you've connected.
Right, which dramatically reduces that vendor lock-in problem.
Hugely.
Yeah.
Secondly, contextual intelligence gets a massive boost. LLMs are no longer strictly limited to their static training data. They can fetch live, up-to-date information on demand.
Like the latest sales figures from a CRM.
Exactly. Or the current version of a company policy document from an internal wiki. Real-time context.
Okay, what else?
Third, and this is crucial, especially for businesses, security and control are greatly enhanced.
Oh, so?
You can run these MCP servers within your own infrastructure, behind your firewall. You can enforce explicit permissions who can use what tool, and you can define strict boundaries for AI actions. For instance, you can easily configure it to require user approval before the AI performs any potentially destructive action, like deleting data.
That's important. Okay, any others?
And finally, there's the rapidly growing ecosystem. We're already seeing what people are calling an MCP market pop up.
A market, like an app store.
Kind of. A collection of ready-made MCP servers for everything from Slack and GitHub to databases and specific SaaS tools. This just accelerates development significantly for everyone building AI applications. They don't have to build the wrappers themselves.
This really sounds like it could become truly ubiquitous for AI integrations. I mean, do you foresee a future where MCP is as common for AI as, say, USB-C is for our devices? Or is that perhaps too ambitious?
Honestly, I don't think it's ambitious at all. Many in the industry genuinely believe MCP will become just that, truly ubiquitous.
Really?
Yeah. Remember that taco shell for AI analogy?
I do.
The idea is it could become the universal container everyone uses to wrap their AI tools and data losses. We might soon see major AI platforms, the big models, the agent frameworks, converge on MCP as the standard way to connect outwards. Which would
mean?
It would mean tools and models from different vendors will just interoperate smoothly. In the very near future, you might find that an AI agent comes with MCP support right out of the box, ready to plug into whatever services you need, just seamlessly.
Wow.
It's actually hard to imagine the next generation of truly useful AI agents not leveraging something like MCP.
Okay, but no new technology is ever perfect right out of the gate. What are some of the challenges or hurdles that MCP still faces, and how is the community addressing them?
You're absolutely right. There are definitely growing pains. One challenge is simply infrastructure overhead. If you're a large organization deploying dozens of these MCP servers, running and managing them can become resource intensive.
Makes sense.
Another is ensuring the AIs are, well, smart about how they actually use the tools they're given access to. An ill-tuned or poorly prompted model might misuse a tool despite having access, right?
Yeah, like repeatedly calling an expensive API when it doesn't need to.
Exactly. But the good news is the community is actively working on solutions. We're seeing things like MCP Guardian sidecars being developed.
Is it sidecars?
Yeah, these are like little helper components that sit alongside the MCP server to monitor and enforce policies on AI tool use. Things like rate limiting, cost controls, or maybe even input-output validation.
Okay.
We're also seeing stronger authentication mechanisms being integrated, like support for OAuth 2.1, so tools can be accessed securely on behalf of specific users. And there are efforts to provide much richer metadata about tools and resources.
Richer metadata? Like what?
Yeah. So an AI can understand, for example, if a tool might cost money to use each time, or if a resource contains sensitive PII data. This allows the AI to act more responsibly and make smarter decisions about which primitives to use when.
So still evolving, but the direction seems clear?
Definitely. Despite these growing pains, MCP's core mission is just incredibly compelling, bridging that gap between LLMs and the real world in a structured, universal way. It takes what used to be this really messy, bespoke process of giving an AI more information or more agency and wraps it neatly into a clean, well-defined protocol.
So it packages tools, resources, prompts.
Right. By packaging external tools, resources, and prompts in this single open specification and using that discovery-based client-server model, MCP just makes advanced AI integration simpler, much more predictable, and far easier to scale.
And the result?
The result is it greatly boosts what AI applications can actually achieve. It moves them from being these isolated language prediction machines to becoming truly integrated, context-rich problem solvers.
So wrapping this up, what does this all mean for you, the listener? Why should you care about MCP?
Well, fundamentally, MCP is empowering developers to build far more versatile AI applications and to do it faster without reinventing the wheel for every single integration.
And for the AI models themselves?
It's enabling those models to be much more context-aware and action-capable. It grants them this safe, standardized portal to the outside world to real-time data and real-world actions.
And for organizations trying to actually use AI effectively?
Crucially, it's empowering organizations to finally harness AI effectively by hooking these powerful models into the specific tools and data they care about most, their CRM, their knowledge base, their internal APIs, all while maintaining control and security through a common protocol. It's really helping turn those isolated AI models into truly connected, useful, intelligent agents.
So it's making AI more practical, more integrated.
Precisely.
You know, the sources mention that MCP significantly reduces the friction of weaving external data and actions into an AI's actual thought process.
Yeah, that friction point is key.
And as AI only gets hungrier for more data, more context, more agency, having that frictionless interface seems like it will be absolutely crucial for its evolution, doesn't it?
Couldn't agree more. It feels essential for the next step.
So maybe a final thought for you to consider. How might this universal port for AI soon become so common, so foundational, that we simply take it for granted, just like we do with USB-C today? How will your own AI assistants evolve once they can seamlessly interact with all your apps and data?
Imagine it fetching details from your calendar, drafting emails for you in your style, pulling data from your company's CRM, maybe even updating a shared project document, all within a single, fluid conversation. That's the potential MCP unlocks.
We really hope this deep dive has given you some significant aha moments about this quiet revolution happening behind the scenes of AI. Definitely keep an eye on MCP. It's really shaping up to be a foundational layer for the next wave of AI innovation, making AI truly plug and play.